Okay, so let's remind ourselves, as I approach 3, that little plus sign means coming in from the right side. As I approach 3 from that right side, what's that limit going to be? Where's my lightsaber end up? At 2. I love it. What about as I approach 3 from the left side? My lightsaber ends up at 2. If there's no exponent, I come in from both sides, and my lightsaber ends up at 2. You guys, what is f of 3 asking? F of 3 is asking for a point. When x is 3, what's my y? 2. Boom. Let's go M. 4 from the left side. 4 from the right side. My bad, from the positive side. Does the graph even exist over there?
No.
No. So we're going to say it doesn't exist. What about from the left side? We end at 1. From both sides, could I even come in from the right side? So it doesn't exist. 0 from the right side. My saber ends at 1. What about f of 0? That point there is 1. Good. And then we're good. Let's talk about y. What happens as I approach 2 from the left side? What would you say this part equals? 2 from the left side. -1. So on this guy, I'd say, does -1 equal what f of 2 is? What is f of 2? It's also -1, so I'm digging 1. 1 is I'm good with. So I'm getting rid of A and B. A and D. Cool. Okay. Do we like 2? As I approach 6 from the left side, what's that limit? Where's my finger end up? -1. What about as I approach 6 from the right side? -1. Does -1 equal -1? I'm digging it. Okay. How about here? What's the limit as x approaches 6? There is no exponent, so we got to come in from both sides. What's my limit as x approaches 6? -1. Does that equal what f of 6 is? What is f of 6? Yeah, those do not equal, so I'm not down with 3, so the answer would be 1 and 2. I think, what's going on at 2? Does anyone have any idea what's going on when x is 2? Huh.
Oh, there's an asymptote.
Why is there an asymptote?
Because it makes the denominator 0.
Yeah.
But it doesn't make the numerator.
Right. You guys, x minus 2, when the denominator is 0, that's when we have a vertical asymptote. So at 2, let's go ahead and just sketch. We've got a vertical asymptote at 2. Then our graph is looking a little something like this. Woo! And then it's like, woo! Who knows what exactly is going on? But that looks ish. Whoops. Ish what's happening. Let's talk this through. Look at this. This was saying, hey, what's happening as x approaches 2 from the positive side? Here's 2. If I'm coming in from the positive side, what are we going to? Negative infinity. Or, say it again. Exactly. So if Mark says negative infinity and Dean says does not exist, me and AP will say, cool. How about as I approach 2 from the negative side? Good. It's going to positive infinity, or it's going to does not exist. I will take one or the other. You do not need to write both. When I say I mean AP will also. Right here, what about 2?
Well, 1.
Right. Do you agree my lightsabers are going in opposite directions at 2? So we're going to just say does not exist. That one I don't want you to say infinity because one's negative and one's positive. So let's definitely only say does not exist there. I got capiche? Okay, great. Let's remind ourselves how this limit doesn't exist, and we're going to draw ourselves some pictures. It says my function approaches a different number from the right side of C than it approaches from the left side. So you guys, let's just draw ourselves a little, there's C. And for the limit to not exist, it's saying from the right side, my limit's approaching some different number than it is from the left side. Is that an example of that?
Yeah.
Okay, my function increases or decreases without bound as x approaches C. What do you think that means, without bound? Say again. There's an asymptote. If we are approaching or increasing or decreasing without bound, I'm going to infinity or decreasing to negative infinity. So what could a graph of that look like? I'm going to say here's C. And at C, I've got a vertical asymptote. The only time I can approach infinity is with some types of asymptotes, vertical or slant. And then I'm just going to say this side, we could make them both go in the same direction. That's fine. That one's going increasing or decreasing without bound. Without bound, that's going infinitely high at C. Limit does not exist. And maybe we just write that off to the side. Limit does not exist. The limit as x approaches C does not exist. Anyone know this word? Oscillates. What does it mean if something oscillates? Okay, so let's go have some fun. Let's go graph the sine of 1 over x in your calculator. You guys, first of all, let's all make sure that we are in radians. So if you go to mode on your calculator, we got to make sure we're in radians. Does everyone's graph look like this if you're in radians? Holy smokes. So when we draw this and we're saying, let's do, ours was literally like this. Woo, woo, woo. Like it's in crazy. And you guys, the limit here, so the limit for this one as x approaches 0, we're doing this at the origin. This one also doesn't exist because it's so insane that we don't know what's going on in there. But isn't that wild that when it wasn't zoomed in, it looked kind of fine. We good with that? Let's flip it. White homework packet. Now, this is just talking about limits, given a table and not a graph this time. So this is saying, hey, table above gives selected values out of x, which supports the table. You guys, what x value do you think these x's are approaching from the left and from the right? What x value? Would you say 2 would probably be in between 1.999 and 2.0001? So I'm looking for a limit as x approaches 2. Okay, all these are talking about 2. Okay, great. What's happening to my y values as I approach 2? How about as I approach 2, are my y values approaching the same thing? No. From the left, what do we think my y values are approaching? -1-ish. What about from the right? Looks like it's approaching 6. So would we say, oh, the limit as x approaches 2 is -1. Because there's no exponent, that means from both sides they're going to -1. Yay or nay? Nah, fam. What could I add to this to actually make that true? What little exponent could I add to that? From the negative side, that would be -1. But since they don't have that, we're going to cross that off. What about that the limit from both sides equals 6? No, what would it be from the which side? Positive side equals 6. This is saying, hey, the limit from the left side is -1 and the limit from the right side is 6. All right, I'm digging that. We literally wrote that right there. Boop, boop. And then this one, they flipped it, didn't they? From the left, they're saying 6. So we're good with C. On this guy, this top one says, hey, here's a table. You guys, let's go look. What x value do you think we're approaching? 6. I agree. Are all of these 6? That's not helpful, is it? Okay. What y value do we think we're approaching? Look, it looks like an asymptote. How'd you know that, Harvey? What are my y's doing here? They're getting really big really quickly, right, Harville? Really big really quick. What are they doing over here? They're getting really small really quick. So if that's happening, like you said, there's an asymptote. And they're asking the limit as x approaches 6. There's no exponent, so they're saying from both sides, what do we think that limit's going to be if we're doing this? Does not exist. Agreed. Oh, look at these x's. Are my x's approaching 11 or 32? Careful where my x's approaching. My x's are approaching 11, so I'm going to get rid of these two because these x's say they're approaching 32. What are my y's approaching? From both sides? Yeah, agreed. Flip it. 11.5 just talks about some properties, meaning if I've got the limit as x approaches C, does anyone know what K stands for? K is just a constant. Why do they use K instead of C? I don't know. But K would just be like 8 times a function. Just means that and that would just mean that we take 8 times whatever the value of that limit was. For example, we can separate these out. If I've got 2 functions adding together and we need the limit, you can just find their limits individually and add them up. We can subtract the limit as f of x minus the limit of g of x. It's like we can distribute that limit and find them separately. So let's go apply something. Let's go not think too hard. Right here, this is the same as finding the limit. 7 times the limit as x approaches 3 of the function. Did they give us info about the limit as x approaches 3 of f? Up here, what do they say that is? 5. That's 5. So then what do we have to do with our final answer? Multiply it times 7. Final answer? 35. Question. Could I have ended that problem? Could I have ended it in blue, or do I have to go to yellow? End it in blue, people. Might we mistake 7 times 5 and say 34? We might. So let's end in blue. Let's go on this one. The limit as x approaches 3 of g divided by f. You guys, we can do them separately. What is the limit as x approaches 3 of g? They gave us that right there. So we can just say 4 minus the limit as x approaches 3 of f. 5, they gave us that info. Minus, what do you think we would put in for this x?
3.
Yeah, because they're saying my x is approaching 3. This 3 gets applied right there. So 3 squared, we'd be subtracting 9 and just adding 5. Could I end right here and not even square the 9? Because it's 3 squared equivalent to 9. We're done. Cool, cool, cool. How about this one? Ooh, 3 from the positive side. Do we have enough info to know what the limit is as x approaches 3 from the positive side? But of f, if we know the limit as x approaches 3 is 5, does it have to be 5 from both sides for that limit to exist? Doesn't it? So for them to make this statement, the limit as x approaches 3 from the right has to be 5, and the x approaches 3 from the left has to be 5 for them to say that. So I can know, oh, 3 from the right is still going to be 5. So that's going to get me 5 over 11 times, yeah, root 4 is just going to be 2. You could leave it as root 4. You could put it as 2. Either one, I'm good with. If I did have to simplify that, what would that be? 10 elevenths or 10 22nds? 10 elevenths. We put that over 1. 10 elevenths. On to this one, we can kind of break apart a little bit. So if you wanted to write this out, this is like find the limit as x approaches 3, really went together, of h of x, times the limit as x approaches 3 of 2 times f of x, plus the limit as x approaches 3 of 3 times g of x. Like, you can break this apart with whatever helps you see it. And you might not need any of that, and that's fine. But why I like to write it out sometimes is because, do we need this side at all? Or do we only care about the limits? Right here, we have to just care about the limit as x approaches 3 of h. What's that value? The limit as x approaches 3 of h of x. Yeah, it's the limit 1. So because we've got that limit in front, they're trying to throw you off, Ritzy. Yep. So we're going to say, all right, that one's 2 times, and I might just do a parenthesis. And again, so this is us just learning, oh, that limit applies here. We got to do 2 times the limit as x approaches f. What's that going to get me?
2.
Yeah, we've got 2 times another 2, right? So I got a 2 times 2 there. Plus 3 times the limit as x approaches 3 of g. 8. And I wouldn't have expected you to know that. That's why we had to do that together. This is multiple choice. So I would have done 4 plus 24 to get 28. Final answer.
56.
You got it. They want to know just the limit of f of x as we approach 2 from the positive side. Do you think those x values are less than 2? If I'm picturing 2 on a number line, here's 2 on a number line. If I'm approaching 2 from the positive side, I'm coming in from the right side, and to your point, 3 is greater than 2. So I need to know where my x values are greater than 2. Mark so good, and use that function. You know what I'm saying, people? Okay, so how I would say that is I'd say the limit as x approaches 2 from the positive side of 4x plus 3. I'm going to put that function that Mark just told me to use right there. Because when x is greater than 2, that means I'm coming in from the positive side. Then, Mark, all we got to do is plug this value of 2 in.
And you go to 11.
Yeah, we don't plug in a little bit bigger than 2. We plug in 2. 4 times 2 is going to get me 8 plus 3 is 11. 0. Does that limit now exist? So just because my individual functions limits didn't exist, when I compose them together, add them up, they can exist then. Okay, last thing I want to practice. This, an AP might give you a question like this. As x approaches 1, you guys, if they give you a problem, you can just substitute that value in. You say, all right, as x approaches 1, I'm just going to go plug that in. And let's do that without our calculator. What is 1 cubed? Times 12 minus 5 is 7. What if I plug in a 2 over here? 2 squared plus over 4. Final answer. Nice. If we look on a graph, boom, this graph has the point when x is 2, my y is 3. Could I just plug in a c? Sure, what would that be? You got it. Seems a bit redundant, right? So just knowing whatever it is, we can plug it in. C to the 8th minus 5c minus c cubed over c squared plus 15. A bit redundant, but it's helpful.